the intercepts of quadratic functions. Now, recall that when you're finding the intercepts of an equation, there were two steps. Like if you're finding the x-intercepts, you would set the equation or set y equal to 0, solve for x. And if you're finding the y-intercept, you let x equal to 0, solve for y. Because if you think about it graphically, that if we had, let's say, a quadratic, the graph of a quadratic function, which you'll see in the college algebra class, is a parabola. So it'll look something like this, like a U-shaped. Although weird looking U though too. So the y-intercept, that would be where the graph intersects the y-axis. So remember, if it's on the y-axis, its x-coordinate is 0. And then the x-intercepts, those would be where the graph intersects the x-axis. So remember, that's the x-axis, that's the y-axis. So if it's on the x-axis, we didn't go up, we didn't go down, so the y-coordinate is 0. Okay, so that's how you in general find your x and y intercepts. So let's talk about it for quadratic functions. Now, for that, let's recall some basic factoring of some quadratics. So let's look at these 4 examples. So if we had first to factor the following quadratic functions, the first one is f of x equals to x squared plus x minus 6. So if you were to factor this, well, let's see, since the leading coefficient is 1, we would think, okay, there would be an x here, an x there, and then for the constants, you would think, okay, what are two numbers whose product is negative 6 and whose sum is 1, the coefficient of the x term? So in that case, that would be what? Plus 3 minus 2, right? And then looking at this next example, if you had f of x equals to 3x squared plus 6x, remember, whenever you're trying to factor at all, the first step is always, can you factor out a greatest common factor, the GCF? So if you look at these two terms, they're both, the leading coefficients are divisible by 3, and both of these two terms have a factor of x, so we could factor out the 3x, and we'd have left over x plus 2. Now looking at this next example, if we had f of x equals to x squared minus 16, well, if you remember, that's an example of a difference of two squares, because that's what? X squared minus 4 squared. So this would factor to x minus 4 times x plus 4. And then looking at this final example here, what if we had f of x equals to 3x squared minus 13x minus 10? Now in this case, this one does factor. It's just more difficult to see how it factors. So let's see. Luckily, the leading coefficient 3 is prime, so we would think, okay, if it does factor, we'd have a 3x there, an x there, and then we got to figure out the two constant terms whose product is negative 10, and when we multiply it out, we would get this negative 13x in the middle. And what it turns out in this case would be 3x plus 2 times x minus 5. Now, we were talking about finding the intercepts, and we're going, okay, why are we factoring? Well, the reason why we would factor is if we're finding our x-intercepts, remember you let y equal to 0, which in this case, this is written as f of x equals to x squared plus x minus 6. So y, f of x, those are interchangeable. So when we're finding our x-intercepts, you set the function equal to 0, and then you solve that resulting equation. So if we have x plus 3 times x minus 2 equal to 0, so remember this is that quadratic equation, and luckily it's already factored. So by the zero product property, that if x plus 3 times x minus 2 is equal to 0, then either x plus 3 is equal to 0, or x minus 2 equals to 0. And so solving for x, we get what? X is negative 3, and x is 2. So our two x-intercepts in this case would be the points -3, 0, and 2, 0. And we would do similarly for the other three examples to find the x-intercepts. So that's one way you would find your x-intercepts, but that's only if the quadratic function is factorable. So what if it's not factorable? Well, if you remember, there was what was called the quadratic formula. So if it's written in standard form, if you have the quadratic equation ax squared plus bx plus c equal to 0, any quadratic equation can be solved using the quadratic formula, which is x equals to -b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are real numbers, and a is not equal to 0, because then it would be a linear equation and not a quadratic one. Okay, so we'd use the quadratic formula in the cases when we can't factor or it's not easily factorable for the quadratic function. So let's look at a couple examples of this. So let's say if we said set the function f of x equals to 2x squared plus 6x minus 5 equal to 0, so for finding our x-intercepts, and let's solve the resulting equation. So if we have the quadratic equation 2x squared plus 6x minus 5 equal to 0, and we wanted to solve this, well, in this case, what our a is 2, our b is 6, our c is -5. So plugging those into the quadratic formula, we'd have x equals to -b, so -6, plus or minus the square root of b squared, so 6 squared, minus 4 times a, which was 2, times c, which is -5, all over 2 times a, so 2 times 2. So that'd be -6 plus or minus the square root. Let's see, so that would be 36, and then -4 times 2 times -5, so that would be plus 40. All over 2 times 2, so that would be 4. So let's see, so that would be -6 plus or minus the square root of 76 all over 4. And then remember, if they want you to simplify this, remember to simplify this radical, you could think, okay, for 76, does 76 have any factors which are perfect squares? And we could think of this, the square root of 76 as the square root of 4 times the square root of 19, because 4 times 19 is 76, all over 4. Now the reason why we do this, the square root of 4 would give us 2, so this would be -6 plus or minus 2 square root of 19 all over 4. Now, what you can do next, that this would be, you could write it as two separate fractions. So this would be -6 over 4 plus or minus 2 square root of 19 over 4. Which would be, let's see, -6 over 4, so that's -3/2, plus or minus here, like the 2's cancel, so you'd have square root of 19 all over 2. So our two x-intercepts in this case would be, well, let's see, for one is the x-coordinate is -3/2 plus square root of 19 over 2, and then the y-coordinate's still 0 because it is an x-intercept. And the other x-intercept, the x-coordinate would be -3/2 minus square root of 19 all over 2, and then comma 0 for the writing it as an ordered pair. And then you can plug that into your calculator and see what is the actual value of that number. Now, let's do one more example, and it's going to be a special case. So let's set the function f of x equals to 5x squared minus x plus 3 equal to 0 and solve the resulting quadratic equation. So again, if finding our x-intercepts, we'd set our function equal to 0. And then this is not easily factorable, so we think, okay, let's try to use the quadratic formula. So in this case, A is 5, B is -1, C is 3. So that would be, plugging those into the quadratic formula, we'd have x equals to negative b, so negative -1 plus or minus the square root of b squared, so -1 squared minus 4 times 5 times 3, all over 2 times a, so 2 times 5. So this would be 1 plus or minus the square root, let's see, -1 squared, that would be 1. And then 4 times 5 times 3, that would be what, 60. So we'd have minus 60 all over 10. So that would be 1 plus or minus the square root of -59 all over 10. Now remember, if you have a negative value underneath the radical, then what that means is that this is a complex number, so there is no real solution. But now, what does this mean graphically? What this means graphically is that if you end up where the solution, when you set the function equal to 0, is a complex solution, then it means that there are no x-intercepts. It could look something like this, or it just is always above the x-axis, or maybe it's always below the x-axis, so it never actually crosses the x-axis, so there are no x-intercepts. Now, really quickly, before we end this, is finding the y-intercepts. Now, remember we were saying for the y-intercept, so you let x equal to 0, solve for y. So to find our y-intercept, what we would simply do is find, okay, what is f of 0? And in this case, we'd have 5 times 0 squared, so that's 0, then minus 0, so and plus 3. So our y-intercept would be the point 0, 3. Now it's nice when the function, the quadratic function, is in this standard form, because all the x terms will just become 0. So the y-intercept would just be whatever the constant is. So like, let's say for this one, our y-intercept would be the point 0, -5. For this one here, well, for the first one, f of x equals to x squared plus x minus 6, the y-intercept would be 0, -6.